There's a kind of secret language that powers just about everything you touch. Your phone, Netflix, even the AI that's changing our world. It's got this kind of intimidating name, linear algebra. But what if I told you it's all based on math so simple, you're already using it every single day? Stick around and I'll show you the hidden engine that makes the modern world tick.
So let's just start with a really simple question. You look at a picture, right? You see objects, colors, maybe a whole story. But when a computer looks at that exact same picture, what does it see? How in the world does an AI know that's a car on the street when, to a machine, it's all just pixels?
Well, here's the surprising answer. It doesn't see a car, not like me do anyway. A computer doesn't see a cat or a face or a landscape. It sees a grid. For a machine, the entire world is just this massive, perfectly organized spreadsheet full of numbers.
And this, right here, is the key. To a computer, that beautiful photo is just a big grid of pixel values. A song? It's just a long sequence of numbers that represent sound waves. Even the words you're reading on the screen right now get converted into numerical codes. Every single decision an AI makes is really just the result of a giant math problem. And linear algebra? That's the language that lets us talk to computers in their native tongue, the language of numbers.
So, what is this language, really? Let's just strip away all the scary, complex-sounding stuff. At its heart, linear algebra is just the math that helps us organize a bunch of numbers and work with them all at the same time. That's it. It's not about just one number, it's about whole groups of them working together. Okay, so how do we get from a single number to something powerful enough to run an AI? Well, it all starts with a few really simple building blocks. Let's take a look at the absolute basics. All right, the simplest piece in our entire toolkit is something called a scalar. I know it sounds like a fancy scientific term, but don't let the name fool you. It is just a formal way of saying a single number. Yep, that's it. Just one value. And you use scalars constantly without even thinking about it. The temperature outside, that's a scalar. Your age? A scalar. The price of your coffee? The speed you're driving. Every single one is just a single value, a single piece of information. That's a scalar. Okay, so a single number is useful, but the real world is obviously more complex than that. What if we need to describe something using multiple numbers? Well, that's where the vector comes in. A vector is simply a list of numbers, and they're arranged in a specific order that gives a meaning. So this is the big leap we're making. We go from a scalar, just one piece of info, to a vector, which is like a structured package holding multiple related numbers. We're going from one little data point to a whole list of them. And this is just incredibly powerful. A vector can represent your exact location on a map with an X and a Y coordinate. Or it can hold a person's stats, like their height, weight, and age, all in one convenient place. It can even store the red, green, and blue values for one single pixel in a photo. It's all about grouping related data together. All right, so we've gone from one number to a list of numbers. What's next? This is where the real power tool of linear algebra comes into play, putting all those lists of numbers into a simple table. And that table has a name. It's called a matrix. A matrix is just a grid of numbers, all organized neatly into rows and columns. So if a vector is a list, you can pretty much think of a matrix as a spreadsheet. Honestly, this is the best way to think about it. For all intents and purposes, a matrix is just an Excel table. It's a grid for organizing entire lists of data, which makes it super easy for a computer to work with.
And here's a perfect, simple example. We call this a 2x3 matrix. Why? Because it has 2 rows and 3 columns. See? Just a simple grid of numbers. Nothing scary about it at all. So we've got scalars, vectors, and matrices, single numbers, lists of numbers, and tables of numbers. Now for the really cool part. Let's see how these simple pieces get put to work to let an artificial intelligence actually learn. It really boils down to a pretty simple 3-step cycle. First, the AI gets its input as vectors, say all the pixel values from an image. Second, it processes that data through its neural network, which uses huge matrices to hold all its knowledge. We call these weights. And finally, it learns by just slightly tweaking all the numbers in those matrices. This cycle, input, process, adjust, that is learning for an AI. And why does any of this matter? Well, because without this simple mathematical engine, we just flat out wouldn't have the technologies that define our world. No image recognition on your phone, no ChatGPT, no Netflix recommendations, and definitely no self-driving cars. It's all built on this foundation.
So here's the most important point. With just these basic building blocks, you are equipped with what you really need to know. You are absolutely ready to start seeing the digital world in a completely new way.
But maybe you're still thinking, okay, this is cool and all, but do I need to be some kind of math genius to actually use this stuff or get into AI?
No, absolutely 100% not. And that might be the biggest takeaway from all of this.
The reality is, computers do all the heavy lifting, all the actual calculations. Your job, if you want to build things with this technology, is to understand the concepts. The source material says it perfectly. Understanding the ideas is far more important than memorizing equations. So, by getting a handle on scalars, vectors, and matrices, you've done way more than just learn a little math. You now basically understand the fundamental language of all modern technology. You're fluent in the logic that builds the entire world around us. And that leaves us with just one final, really exciting question. Now that you speak the language, what are you going to build with it?